So modular arithmetic is often called clock arithmetic, and for good reason. So normally we think about numbers laid out on a number line, you see 0 and positive numbers to the right, negative numbers to the left. Modular arithmetic wraps numbers around a clock or a circle, and it's cyclical, obviously. So this is kind of a very different way of thinking about numbers. But we're used to this because we use a clock all the time, and this is kind of our day-to-day routine. So I'll give you your first modular arithmetic problem. Let's say you leave your house for work at 8 a.m. and you've promised yourself today you're coming back in 9 hours. You're really, we're busy teachers, but you've promised yourself you'll be home in 9 hours. So what time is that? So, it's easy for us because we use this all the time, but let's just, just kind of do it in a simple way. So from 8, we can count ahead 9 hours. So we can just hop ahead, count 1, 2, 3, 4. But then here's the problem because the number resets because it's circular and it's on the cycle. So then, but that's okay. We just keep going ahead. 5, 6, 7, 8, 9. So the answer is if things go according to plan, you'll be walking in the door at 5 p.m. So that's your first modular arithmetic problem. And that is 8. That's 8 plus 9 mod 12 equals to 5. So I think an easy way to think about this, especially because we just spent a lot of time doing arithmetic in different bases, is to think about this problem. Let's do it in base 12. Let's just do this addition problem. So 8 base 12 plus 9 base 12, the answer is not 17. We have to convert that answer to base 12. So how many 12s fit into 17? Well, it goes in once with a remainder of 5. So to write that answer in base 12, there is a 1 in the 12 to the 1's place, and then there's a 5 in the 12 to the 0 place. Now, modular arithmetic only cares about this 5. It only cares about once you've divided out all the 12s, what's left, what's in this position in the far right, the 1's position. So that's our 5 o'clock. And if you think about it, why does that work? Well, here's our 5 o'clock. We can add 12 hours and we're at 17 o'clock. We would never say that. We would say 1700. If you're in the military, you might say 1700. But, you can keep adding 12 hours. You can go ahead 36, 48, however many, 72 hours. But you're still going to be in this position on the clock. So really, modular arithmetic doesn't care how many times you cycle around. They just care about this spot.